LCM will be divided to both, will be twice ut plus 2 plus 1 by 2 into at square. This 2 get cancelled. This shows distance traveled. Another formula for it is ut plus 1 by t at square, relation number 3. So relation number 3 we are getting distance is equal to ut plus half at square. So these three all together is one word, we call it equations of motion. These three will describe everything about the motion that it is related to a body's movement. Now some special cases are there. The special cases are there. Final velocity is equal to initial velocity into a into t. That means if a body starts from rest, means its initial velocity is 0. Obviously, that time final velocity will be a into t only. U will be simply out because it is starting from rest. If final velocity is 0 at times, when you say in moving condition, body comes to rest, finally comes to rest. That means the final velocity will become the magnitude 0. That means this final velocity will be over. Then this u plus at, then final velocity being 0, obviously your formula will stand u minus v by t, which is a negative kind, which is the negative direction of acceleration. That means it will be called retardation. That means at times when v is greater than u, this says there is acceleration, and when v is less than u, there will be negative acceleration. This negative acceleration is called retardation or deacceleration. So at times it will be, these two conditions are there. So from here only we get the values for acceleration as positive as a negative. Keeping that in mind, final velocity being 0, u square is equal to twice, it is one thing missing, twice as, u square plus twice as, then this u square plus twice as here, final velocity being 0, then u square will give you the negative acceleration there again. That means if the velocity, final velocity is less than initial velocity, again the acceleration value will be 0. So in negative term, the special cases, if acceleration changes to retardation, these all will change. You refer to your book, v is equal to u minus at, v square is equal to u square minus twice as, and third is there, that is s is equal to ut minus 1 by 2 at square. Why? All acceleration will change to negative form if final velocity becomes less than the initial velocity. These are the special conditions. These are all the motions on a surface in a rectilinear direction. In the space, if it happens, this formula will go change. Acceleration will be marked as g, that is acceleration due to gravity. So at times a body is thrown vertically upward, acceleration due to gravity will be negative. And when a body falls freely, say I am just leaving this chalk, it falls freely down, its acceleration is going on increasing in the positive direction, so acceleration due to gravity mark will be positive. That's why v will be equal to u plus gt, g for acceleration due to gravity, for body falling freely down under gravity. V square is equal to u square plus twice gs. In place of s we can write h also. That is v square is equal to u square plus twice gh. H is for height. Height is a kind of distance traveled. It is a gravitational motion, so distance traveled is nothing but the height. And this height is equal to ut plus half gt square at times when the body falling freely. If the body is thrown vertically upward, then acceleration due to gravity will become negative. That time the value will be v is equal to u minus dt. V square will be u square plus u square minus twice gh, and h is equal to ut minus half gt square. These are the special cases that you can apply at times when it is required for your numerical purposes or things as such. So that way, this is one way of graphical way to take out the values of the equations of motion. We got it. In your book there is alternative method is also given. Alternative method is done by the formula average velocity into time. Just check the line. Average velocity into time. In case of average velocity into time, the average velocity stands for the sum total of initial and final velocity divided by 2. That is half the sum total of the initial and final velocities. From there only you will carry on the whole of this system. In place of geometrical form here, it will be directly plain algebraic form. So I don't think you need any help of anyone. I don't think it, but I just suggest you go for this algebraic purpose. The formula will stand as distance traveled will be equal to average velocity into time. By giving u plus v by 2 into time, automatically lines will be coming up in your mind by the same process. Once you will eliminate time from the first equation, that is v minus u by t, v minus u by a, and the second formula on drawing, it will be u plus v by 2 into t. T will be as usual. V will be eliminated. As v is eliminated in terms, here u plus at form, the same way it will be changing there only. So that is not a very big difference of working sets on. I now suggest you going for its applications. Mind, applications means how you tackle the numerical problems. Well, I take up a few numericals for you. Just give you a guideline how you tackle, how you work out the numericals. I take a simple case, a simple one, rather the simplest one, so that you can catch the idea of working out the numerical problems. Doing numerical is also highly technical. Means you have to give a thorough informations while doing numerical. From your textbook I read from page number 54, question number 1, the simplest kind. Just hear and just correlate with your textbook. What textbook I have that has the 54 number page, and there I am seeing it. The question number 1, that is concise physics.